Okay, we're taking a look at problem 2 using a table, an equation, and a graph. So we have both Carrie and her sister Kim were born on October 25th. Wow. But Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? So if we made a table, we know when Carrie was 1, Kim was 3. When Carrie was 2, Kim was 4. When Carrie was 3, Kim was 5, and so on and so forth. So each time I'm adding 2. So if I write an equation, I know that I'm just going to be adding 2 each time. So y equals x plus 2. So if x is Carrie's age and y is Kim's age, I know that all I need to do is add 2 to find out what Kim's age is. If I graph it, I know that I'm going to start here at 2 because that's when that's the first instance that I have for Kim's age in relation to Carrie's age because they're 2 years apart. And then I would just graph it each time, each year I would go up. Okay? So now let's look at got it too. It says we'll run 6 laps before Megan joins them on the track. They then run together at the same pace. How can you represent the relationship between the number of laps Will runs and the number of laps Megan runs? So if I have Will and Megan. So I start off Megan with 0 and Will goes to 6. After her first lap, Will is at 7. After her second lap, Will is at 8. After her third lap, Will is at 9. And after her fourth lap, Will is at 10. And after her fifth lap, Will is at 11. So there's my chart. And so it's my table. As far as my equation, oops. It doesn't matter which one I choose, but I can say that y equals x plus 6, where x is Megan's number of laps and y is Will's number of laps. And I can check that out because I know that if I plug in 0 here, that I get 6 for Will. And if I plug in 1 for Megan here, I should get 7. So each time I'm adding 6. And so if I graph it, Will is on my y, Megan is on my x, and I know I'm going to start here at 6. So there's my first. And it's just going to be a straight line. 7, 8, 9, 10. And here we have 1, 2, 3, 4, and so on. Okay? Then it says describe how the graph in problem 2 would change if the difference in age were 5 instead of 2 years. So the problem would change. Instead of starting at 2, I would start at 5. And I would still have the same rate each year. They go up, but instead of starting at 2, I would start at 5. And we can look at the other parts as well. So when I do 1, this would be 6. When I do 2, this would be 7, and so on and so forth. I hope that this helps.